All right, so we're starting our final unit right now. It's a shorter unit, and it's looking at arithmetic and geometric sequences and then using those number patterns to write formulas that we could use to represent them. So a sequence you probably have been looking at since you were in kindergarten. I mean, my daughter right now, she looks at number patterns and then has to write the next number in the pattern. So an arithmetic and a geometric sequence is just a sequence or a list of numbers in a particular order, okay? So for example, if I have 3, 6, 9, 12, if you notice, we probably could pick the next number, or you could recognize the next numbers in the pattern because it seems like we're increasing by 3 for each time that I am writing the next number in the sequence, okay? And so we could continue that for as long as we needed to. Some vocabulary terms. So in a sequence, each one of these values or each number is considered a term, all right? So 3 is the first term. 6 is the second term. 9 is the third term. 12 is the fourth term. Okay, and instead of having to write those values out or write out the word term every time, what we do is we refer to the first term of the sequence as a sub 1. So let's see how I have a little subscript right here. So that's representing the first term in the sequence. The second term in the sequence is a sub 2. So if I wanted to I could make a table here, and eventually we'll do this. If I have a sub 1, the first term is 3. A sub 2, the second term is 6. A sub 3 would be 9. A sub 4 would be 12. And I could continue up to any number, which we'll call a sub n. Okay, so eventually we're going to start writing formulas, and I'm going to ask you for what is the 10th term, but I'm not going to say 10th term. I'm going to say evaluate a sub 10. Okay, so that's kind of where we're headed. Most sequences have patterns. Two types of sequences we're going to study are arithmetic and geometric. I know it looks like arithmetic, but we happen to pronounce it a little bit different when we're talking about sequences. So an arithmetic sequence is a sequence when each term is found by adding a constant to the previous term. This constant is called the common difference. So when I looked at the first sequence I gave you, 3, 6, 9, 12, 13, this is an arithmetic sequence because I am adding 3 each time I continue. So we would say that D is equal to 3. We find the common difference. The common difference is equal to a sub n minus a sub n minus 1. And you're like, what on earth does that mean? Basically, it says take any term, and then minus its previous term. Okay, or we can say, honestly, the easiest way is to do the second minus the first. The second term minus the first term. And that's going to give you your common difference. So if I take the second term, which is 6, minus the first term, which is 3, 6 minus 3 is equal to 3, which is why the common difference is 3. So let's take a look at another one. Find the common difference between the following sequence. So if I take D is equal to the second term minus the first term, I'm going to say, all right, the second term is 49 minus 55, and so I get a value of negative 6. The common difference can be negative because in this case, notice how my sequence, the values are decreasing. Because the values are decreasing, then I have a negative common difference. Okay, so the D value is going to be a negative. Okay, so, and I could continue because if I have 55 minus 6, I'm at 49, minus 6, I'm at 43, minus 6, I would be at 37, minus 6, I'd be at 31. So each time I'm subtracting 6. So all we're doing in these first couple of lessons is finding the pattern. Okay, so let's kind of box these up here. So this one had a common difference of a negative 6. Here we had a common difference of a positive 3. Those are arithmetic sequences. We are adding a constant. So that is important. When I have an arithmetic sequence, we are adding a constant, and that constant can be positive or negative. Okay? For a geometric sequence, it's a sequence where each term is found by multiplying the previous term. So we are going to multiply the previous term by a constant. That's a geometric sequence. And we call that value the common ratio, or R. Okay? Common ratio can be found by dividing any term by its previous term, or R equals the second term divided by the first term. One thing I didn't mention in the arithmetic is that you have to continue the pattern to check to see if the pattern continues, because sometimes patterns can seem a little bit tricky. For instance, and I'm kind of going off on a tangent, it's been a while since you guys have had one of those. If I say 1 and then let's say 3 and then 6 and then 10 and 15. So suppose that I have this as a sequence. If I just go off of the first one and I do, okay, well this looks like it's adding, so I'm going to say that the difference is equal to 3 minus 1 or 2. Is the common difference 2? Do I add 2 each time? Well, no, that doesn't hold up. Okay, I am not adding 2 each time. So then I say, all right, is it a geometric? If I take the second divided by the first, am I multiplying by that every time? So R equals 3 divided by 1. 3 divided by 1 is 3. So am I multiplying by 3 each time? So 1 times 3 is 3. 3 times 3, be careful, it's not 6. 3 times 3 is 9. And 6 times 3 is not 10. So I can't use a common ratio. This would be something that would be neither geometric or arithmetic. So it's not arithmetic, nor geometric. And this would be a different type of pattern that we are not going to cover in this class. All right, so sorry, I went off on a tangent. But if I look at my ratio of my second divided by my first, find the common ratio. So I'm going to take 20 divided by 8. 20 divided by 8, if I open up my calculator here, 20, oops, clear, 20 divided by 8, I get 2.5. So this is 2.5. Check the other values. If I do 50 divided by 20, so I did any term divided by its previous term, any term divided by its previous term, any term divided by its previous term. So if I do, or you can also do multiplication, but let's do 50 divided by 20. So if I, if I go 50 and divide by 20, I get 2.5. And then the other one was 125 divided by 50. 125 divided by 50 is 2.5. So I do get the common ratio is 2.5. Find the common ratio. So now we're saying find the common ratio, but I would just want to, oh, not ration. I just wanted to check. So again, I'm going to take the second term divided by the first term. Negative 1.5 divided by 1.25. And so I get negative 1.5 divided by, sorry, I forgot what it was. 1.25. So I get negative 1.2. I'm going to check it in a different way this time. Sorry, I'm all over the place. Negative 1.2. So what I'm going to do is I'm going to multiply. Is 1.25 times negative 1.2 equal to 1.5? And multiply by negative 1.2 and see what happens. So I'm going to start with 1.25 and multiply by that ratio. So 1.25 times negative 1.2, and I get negative 1.5. And then I'm going to times negative 1.2, and I get 1.8, which was the next value in the sequence. So it works. R is equal to negative 1.2. Find the common ratio. So sometimes when the values seem to be decreasing, notice 405, 135, 45, you might be tempted to check for the common difference. I know that we're looking at the common ratio, so let's check it. If I do 135 divided by 405, and I actually divide that, 135 divided by 405, I get 0.33333. Now, I can't have these approximation values. We have to know that 1/3, if I go to math and fraction, is, I'm sorry, that 0.33 repeating is 1/3. So in this case, my ratio is actually a fraction. It's less than 1. So then, if I get, that's 1/3. So what I'm going to do is I'm going to multiply 405 times 1/3, and I get 135. What happens if I multiply 135 by 1/3? So I'm going to take 135 times 1/3, and I get 45, which was the next value in the sequence. Okay, so in this case, my common ratio is 1/3. So what you're going to do for this part is determine whether the sequence is arithmetic, geometric, or neither. If it's geometric, I want the common ratio, and if it's arithmetic, I want the common difference. So if I look at these values first, look for a pattern. I see I'm increasing by 2, I'm increasing by 3, so it can't be D. So it's not arithmetic. Because when I add, I'm adding 2, then I'm adding 3. Common difference means it has to be the same number. So then I'm going to go ahead and I'm going to check the common ratio. So if I do 2 divided by 0, that's undefined. If I do 5 divided by 2, that's 2.5. So I don't get the same value, which means this would be a neither. It is not arithmetic and it is not geometric. Okay? If I look at number 2, notice how the numbers seem to be increasing. So if I go from negative 10 to negative 2, if I take negative 2 minus a negative 10, second term minus the first, I get a positive 8. Well, then if I check the other ones and if I add 8, does that work? Negative 2 plus 8 is 6. 6 plus 8 is 14. 14 plus 8 is 22. And it checks. Therefore, it worked with addition, so my common difference is 8. Okay, let's take a look at number 3. So if I take a look, the numbers, they don't appear they're getting larger, but they are, because I'm going from a negative 5 to a negative 1. That's an increase. So I'm going to try and add. Well, negative 5 plus 4 gets me to negative 1. But negative 1 plus 4 is not negative 1/5, so arithmetic doesn't work. So then we check division. If I divide negative 1 divided by negative 5, I get 1/5, or 0.2. If I multiply negative 1 times 1/5, I get negative 1/5. If I do 1/5 times 1/5, so let's do a calculator if you struggle. 1/5 times 1/5. Okay, I get a decimal, math, fraction, I get 1/25, which is what I had here. So this does check out as a common ratio of 1/5. So this was a geometric, and this was arithmetic. So what you're going to do is you're going to do IXL, and you're basically going to have to decide is the function, the sequence arithmetic or geometric. Okay? All right. Have a great day.